In a technological landscape constantly reshaped by innovation, Google has redefined what's possible with artificial intelligence. The tech giant's unveiling of Gemini 2.0 and significant updates to Project Astra represent a fundamental shift in how AI will interact with and understand our world. These developments mark the beginning of what Google calls the Agentic era, where AI moves beyond being merely responsive to becoming proactive, contextually aware, and capable of independently taking actions on our behalf. The evolution of AI has followed a predictable trajectory until now. Increasingly sophisticated models that can process more data, understand more context, and generate more human-like responses. But Google's latest announcements signal something more profound. AI that can truly understand the world around it, using multiple senses simultaneously, just as humans do. Gemini 2.0 represents Google's most ambitious AI model to date, built from the ground up to enable a new generation of AI agents. These models can now process and understand information across multiple modalities, text, images, audio, and video, all at once, with unprecedented speed and accuracy. This shift to agentic AI is the culmination of years of research across multiple disciplines. What makes this moment significant is that these various streams of development are now converging into systems that can function in ways that feel genuinely intelligent and helpful. Current AI assistants are fundamentally reactive. We issue commands, they respond. Agentic AI flips this dynamic. These new systems can observe their environment, understand context, remember past interactions, and take initiative when appropriate. They're designed to be collaborative partners rather than passive tools. Perhaps the most exciting development is Project Astra, described by Google as a universal AI agent that is helpful in everyday life. First teased at Google I/O 2024, Project Astra has now matured into a research prototype that showcases the true potential of multimodal AI. Project Astra has been designed to understand and respond to the world like people do, using a combination of vision, hearing, and contextual understanding. It can process live video feeds, recognize objects, interpret spoken language even with accents and uncommon words, and engage in natural, flowing conversation. As Greg Wayne, co-lead of the Astra team, describes it, "The pitch to my mom is that we're building an AI that has eyes, ears, and a voice. It can be anywhere with you, and it can help you with anything you're doing." What sets Project Astra apart is its ability to maintain continuous awareness of its environment while simultaneously engaging in conversation. It doesn't just process individual requests in isolation. It builds and maintains an understanding of the world around it, allowing for more natural and contextually appropriate interactions. In demonstrations, Astra has shown remarkable versatility. When pointed at a bookshelf, it can identify specific titles, recall which ones the user has mentioned reading in past conversations, and recommend similar books based on their preferences. When shown a refrigerator's contents, it can suggest recipes based on available ingredients while accounting for dietary restrictions it has learned about the user. The latest version of Project Astra, powered by Gemini 2.0, represents a significant leap forward with several key improvements. Enhanced dialogue capabilities. Astra can now understand and converse in multiple languages, including the ability to handle mixed language conversations and a variety of accents. Expanded tool use. The system can now tap into Google Search, Google Lens, and Google Maps to provide more comprehensive assistance. Improved memory. Astra can now remember up to 10 minutes of in-session interaction compared to just 45 seconds in earlier versions, and can recall previous conversations. Reduced latency. The lag between questions and answers has been significantly reduced, making conversations feel more natural and fluid. Project Astra is currently being tested on both Android smartphones and prototype glasses, giving us a glimpse of how AI might soon become integrated into our everyday lives. The glasses configuration is particularly noteworthy, allowing the AI to literally see the world through your eyes and provide assistance based on what you're looking at. What makes all this possible is the technological marvel that is Gemini 2.0. This new model represents a significant advancement over its predecessors, with several key innovations. Unlike earlier AI models that were primarily designed for text and later adapted for other media, Gemini 2.0 was built from the ground up to be natively multimodal. This means it can seamlessly process and understand information across text, images, audio, and video, without the performance gaps typically seen in retrofitted models. This native multimodality allows for much more sophisticated understanding. Rather than processing different types of information separately and then trying to combine them, Gemini 2.0 can understand the relationships between modalities from the start. Gemini 2.0 Flash now supports multimodal outputs, including the ability to generate images mixed with text and create lifelike multilingual audio through steerable text-to-speech technology. This opens up new possibilities for creating rich, multi-format content. For example, rather than just describing a concept verbally, Astra could generate a visual representation alongside its explanation. When discussing travel plans, it might create a map highlighting key attractions while narrating information about each one. Perhaps most importantly for agentic applications, Gemini 2.0 has native tool calling capabilities built in. It can access Google search, execute code, and call third-party, user-defined functions. All essential components for an AI that can take meaningful actions in the real world. This ability to use tools extends the AI's capabilities far beyond what's contained in its training data. When faced with a question it can't answer directly, Gemini can now search for up-to-date information. When tasked with a computational problem, it can write and execute code to solve it. With the introduction of thinking models like Gemini 2.5 Pro, Google has created AI that can reason through problems before responding. This approach, where the AI takes a few seconds to work backward through a problem, significantly improves accuracy and reliability. This thinking process involves a sophisticated form of self-supervision, where the model evaluates its own reasoning, checks for errors, and refines its understanding before producing a final answer. This leads to fewer hallucinations, better logical coherence, and more trustworthy responses overall. Google has recognized that different applications require different balances of speed, cost, and capability. The Flash series of models, starting with Gemini 1.5 Flash, and now expanding to include 2.0 Flash and 2.0 Flashlight, addresses this need. Gemini 2.0 Flash builds on the success of 1.5 Flash, delivering enhanced performance while maintaining fast response times. Remarkably, 2.0 Flash even outperforms the larger 1.5 Pro model on key benchmarks, while operating at twice the speed. For developers and enterprises looking for cost efficiency, Google introduced 2.0 Flashlight, which offers better quality than 1.5 Flash at the same speed and cost. All of these models feature the breakthrough million token context window, allowing them to process vast amounts of information, equivalent to thousands of pages of text or hours of video simultaneously. The implications of these advancements extend far beyond technical specifications. Imagine pointing your phone at a foreign menu and having Astra not just translate it, but recommend dishes based on your dietary preferences it remembers from previous conversation, or wearing smart glasses while navigating a new city, with Astra identifying landmarks, offering historical context, and suggesting detours based on your interests. Astra could help follow complex recipes, offering verbal guidance while recognizing what stage of preparation you're at through the camera. It could assist with home improvement projects, identifying tools and materials while providing step-by-step instruction. Students struggling with complex problems could point their camera at a textbook or whiteboard and have Astra walk them through solutions step by step, adapting its explanations based on their responses and learning style. In professional learning contexts, Astra could function as an always available mentor. New employees could receive guidance on complex procedures, with the AI recognizing tools, machinery, or software and providing contextual instructions. For people with disabilities, these technologies could offer unprecedented support. Visually impaired individuals could receive detailed descriptions of their surroundings, while those with hearing impairments could get real-time transcriptions and contextual information about speakers and environments. In professional settings, Astra could serve as a proactive assistant that not only takes notes in meetings, but also identifies action items, suggests resources, and even helps draft follow-up communications, all while understanding the full context of projects and team dynamics. While Project Astra remains a research prototype, elements of its technology are already being integrated into Google's product ecosystem. At the Mobile World Congress 2025, Google announced that Project Astra-powered features, such as live video and screen sharing, would roll out in Gemini Live to Gemini Advanced subscribers and Google One AI Premium users. Google's strategy appears to be one of gradual integration, introducing advanced features first to premium users before eventually making them more broadly available. We're likely to see Astra capabilities appear first in flagship Google products, like the Pixel line of smartphones, which have historically served as showcases for the company's latest AI features. As with any transformative technology, these advancements bring both opportunities and challenges. Privacy concerns are particularly relevant for tools like Project Astra, which process video and audio from users' environments. Google emphasizes that it's designing these systems with privacy and security as priority. There are also practical challenges to overcome. Running sophisticated AI models like Astra requires significant computational resources, raising questions about battery life and processing capabilities on mobile devices. Ethical considerations abound as well. How should an AI system like Astra handle situations where users rely on it for critical decisions? What guardrails should be in place to prevent misuse or over-reliance? Google's innovations don't exist in isolation. They represent the latest developments in an increasingly competitive AI landscape, with companies like OpenAI, Microsoft, and Apple all pursuing similar capabilities. What sets Google's efforts apart is the combination of cutting-edge AI models with its existing ecosystem of services like Search, Maps, and Lens. This integration creates a network effect that potentially gives Google an advantage in delivering comprehensive, contextually relevant assistance. While these developments are impressive, they represent just the beginning of the agentic era of AI. As Google continues to refine these technologies, we can expect several trends to emerge. Increased personalization. Future iterations will likely become increasingly personalized, learning from interactions to better understand individual preferences, habits, and needs. Expanded hardware integration. Beyond smartphones and experimental glasses, we may see Astra-like capabilities integrated into a wider range of devices, from household appliances to vehicles. Enhanced proactivity. As these systems mature, they may become more proactive, anticipating needs based on context and past behavior rather than just responding to explicit requests. Deeper ecosystem integration. The line between different Google services may blur further, with AI serving as the unifying layer that provides seamless experiences across applications. Google's latest AI advancements with Gemini 2.0 and Project Astra represent a significant inflection point in the evolution of artificial intelligence. By creating systems that can see, hear, and understand the world in more human-like ways, Google is laying the groundwork for a future where AI becomes a more intuitive, helpful presence in our daily lives. While still in the early stages, these technologies point toward a world where the barriers between digital and physical experiences continue to dissolve, and where artificial intelligence becomes less of a tool we actively use, and more of an ambient intelligence that enhances our interactions with the world around us.